Okay, chapter 17, radioactivity and nuclear chemistry. We're going to go really quick through this. Some of it is just, kind of general information, and there won't be test questions, so you need to read this chapter. There's, some kind of touchy-feely human interest kind of things. Why are we interested in nuclear medicine and radioactivity and stuff? I'm not going to go over that. We don't have time for that. What is radioactivity? We all have heard of it, nuclear bombs and all of this stuff. Radioactivity is the emission of tiny energetic particles by the nuclei of certain unstable atoms. So you have an atom like this, and part of the nucleus comes out. Okay, so this is a big deal, but not everything does this. Radioactive substances do this. And then this violates the law of conservation of mass because now we have the mass changing here. But we got around that by combining the law of conservation of mass with the law of conservation of energy. If you conserve both of them, then it's still okay. So there were a lot of things we talked about earlier, balancing equations and things, and we said you can't change one element into another except for nuclear reactions. So this is the exception part where an element can turn into something else. Because if this particle that's emitted contains protons, then you have a different element because you lost protons, and protons are the identity. They identify what element it is. So when we have particles like this, they're said to be radioactive. It has nothing to do with radios. Many of these particles that are emitted can pass through matter. They can pass through your body. Some of them can go through concrete walls. They can just go through stuff, which is not typical of most matter.